Hey y'all, last video of Unit 2. I've gotten this question a few times and I figured it would be a good idea to just kind of review the unit circle, see where these values come from and kind of what we can do with this. So the first thing we should notice about our unit circle are all these values right here of degrees. I'm saying, well, how can we have all these degrees going on at the same time? And so if you're reading it like that, you're granted and understandably are going to be very confused. But we need to think back on what an angle is. So an angle are two rays with the same origin, back from geometry, that are separated by some sort of degrees right here. We could call that theta, or we could say it's separated by a certain amount of radians. So this is our initial side, and this is our terminal side. For our unit circle, our initial side is always going to be starting at the origin, pointing straight out towards 1, 0, like so. Now our terminal side depends on what angle we're looking at. So that one's the one that's going to be changing as we're going around. So for example, if I decided to make my terminal side intersect my unit circle up here, we know that we're talking about 60 degrees. So here's our 60-degree angle right here. So we could go all the way around. Notice how a full revolution is 360 degrees. The next thing that we're going to want to take a look at is the radians. So radians is just another way of talking about our unit circle in terms of degrees. And the way we can see it is by taking this length right here and calling this 1 radius. If we spin it around 3, 4, 5, 6 times and a little bit, you'll see that 6 and a little bit of this circle's radiuses can fit in the whole thing. So it turns out that value is actually 6.28. So for radians, equals about 6.28 in a full revolution. We could also see this as exactly 2 pi. So going a full circle is 2 pi radians or 360 degrees. Notice how everything is in terms of pi. You want to keep it like that because we want to have a single nice symbol instead of the times 3.14159, etc., etc. So we know how to navigate our way around. We know how the terminal and the initial angle comes in. So our last question is, well, how are these values associated with this angle? So we're going to continue looking at the 60-degree angle, but what I'm going to show you is that we need to connect our terminal side to our y-axis, to our y value, and then we need to also show the x value, okay? So we have an x and a y. Notice how these intersect at a 90-degree angle. So we actually have a right triangle on our hands. We can use trigonometry on this. So I'm going to remember my SOHCAHTOA and see what we can figure out in terms of sine and cosine, and then how to apply the tangent to it. So if we're looking at this right triangle, we know that the O is going to be our vertical side, our adjacent is going to be our red side, and our hypotenuse is actually going to be this third side. Because this is a unit circle, we know that this length going from 0, 0 to 1, well, that's just 1 unit right there. So if we're talking about a circle, it's 1 unit no matter what our orientation is. So this hypotenuse is always going to be equal to 1. From here we can actually see that we can relate our 60 degrees, or our angle, to the opposite over the hypotenuse, as well as the opposite over the adjacent. So, we know our adjacent side is going to be equal to root 3 over 2, because or 1/2, because we're stepping over in the x direction. And we know that our vertical shift is going to be root 3 over 2 to get from our origin to this point along our unit circle right here. So we go over 1/2 up root 3 over 2 steps. And we know if we wanted to take the direct path, it would be equal to 1 step. So if we're checking out our cosine first, or well, let's do our sine. So our sine of 60 degrees in this example is going to be equal to our opposite side, root 3 over 2, divided by our hypotenuse. Well, that's just 1. So we can actually see that the sine of 60 degrees is equal to root 3 over 2. So if we wanted to make this general, we'd say that our sine of our angle is just going to be the y value of our unit circle. So next up we have our cosine of our angle. Cosine of 60 degrees, we'll see from the ca that it's adjacent over hypotenuse. So we have our adjacent side, which is 1/2, divided by the hypotenuse, which is 1. And find that that also simplifies down to 1/2. So in general, our cosine of theta, the cosine of our angle, is just the x-coordinate of here. So the last thing we have is the tangent of 60 degrees, and that's just the sine divided by the cosine. Divided by the cosine of 60 degrees. In this case, that's going to be equal to root 3 over 2 divided by 1/2, or just root 3. So in general, our tangent of our angle is just going to be our y component divided by the x component of our circle at any of these given angles. So we can derive a lot of more interesting ideas from this. I wanted to just leave it at this so we can create a unit circle, or look at our unit circle, understand what it means to revolve around it, as well as how these angles relate to the x and y components right here. So remember, your sine corresponds to the vertical component, the y component. Your cosine corresponds to the x, and the tangent corresponds to basically the slope of your line, more or less. It's the y divided by x, the rise over the run.